Okay, so the first thing I'm going to try is can I put -2 in and get a number? And I can. So if I can do that, that's what I'm going to do. That's what I mean by direct substitution. So we put -2 in, and actually what we're using right now is the quotient rule, but again, you don't need to know that there's a name for it. We're just putting it into the numerator and the denominator and simplifying. Alright, so let's do -2 cubed first. What is that? -8. Four times -8 is -32, right? And -32 plus 1 is? So the limit as x goes to -2 is 31/7. Okay. Okay. And you could make a table to back that up and a graph to back that up, but algebraically, we just use direct substitution to do that. Okay, what about this factoring? Let's show you something where you might need to use some factoring to get rid of a problem in the denominator. So let's say I asked you to find the limit as x goes to -4 of x squared minus x minus 20 over x plus 4. All right, so what happens when we try direct substitution with this one? You get a 0 on the bottom, okay? So what we're going to try to do is we're going to try to factor out this x plus 4, keeping in mind the function is not defined at -4. It's undefined, okay? But if possibly I could factor and I find that the top has an x plus 4, I might be able to cancel it out. So I'm going to factor the top. Can somebody tell me what the top factors into? X minus 5, x plus 4 over x plus 4. Okay. Now, again, the function is not defined. I still can't find it at -4. However, I can find its limit, okay? Because what happens here? Let's cancel these out. Now, I'm left with the expression x minus 5. Can I plug in -4 now? I can. So this limit is just going to be -4 minus 5, which is -9. Okay, and we saw something like that, I think the first day when we were evaluating limits. But I'm going to just put it in my calculator to back it up with a table. Uh-oh. What did I do wrong? Oh, I did +4. Nobody caught that? Instead of -4. Are you seeing it there on the side? That it's approaching -9? Okay. And definitely still an error there, okay, but we can find its limit algebraically then. So that's a little bit of factoring. Let's try another one with factoring. How about the limit as x goes to 3 of x squared minus 9 over x minus 3? So let's factor. This is the difference of squares, x plus 3, x minus 3 over x minus 3. These cancel. I can then use direct substitution and put the 3 in for x right there. This limit would be 6. Okay. I might come back to that later because in our book they do some factoring of cubes, and you probably didn't do that in Algebra 2 at all. There are some cubes that can be factored, so I can show you kind of a strategy for that. Alright, last thing on my list is rationalizing, and this involves sometimes when we get a square root, and sometimes the square root will be on the top and sometimes it will be on the bottom. So let's evaluate, or try to evaluate, the limit as x goes to 9 over the square root of x minus 3 over x minus 9. Okay, so actually this produces what we call an indeterminate form. An indeterminate form means you get like a 0 over 0. It's not just a 0 on the bottom. If I plugged 9 in the top, wouldn't I also get a 0 as well? Okay. So we obviously can't factor this. So what we're going to do is something called rationalizing, and rationalizing just gets rid of the square root. And the way that it works is similar to complex numbers. Do you remember how if I had 3 plus I and I wanted to get rid of it, I multiplied by 3 minus I on the top and bottom? It's similar, except with a radical. So to get rid of the square root of x minus 3, I am going to multiply top and bottom by the square root of x plus 3 on both the top and the bottom, because I can do that to a fraction as long as I do both. Okay, then what I'm going to do is the one I want to get rid of, I'm going to simplify, and I'm going to wait and see. I'm going to leave the bottom alone, okay? What's going to happen here by doing this is we're going to get the square roots to cancel, okay? So let's just do the top. What's the square root of x times the square root of x? X. This is positive 3 root x minus 3 root x. What happens? They cancel. Don't even write them down, okay? Positive 3 root x minus 3 root x cancels, so it's gone. And then what's negative 3 times positive 3? Minus 9. Hopefully you're seeing why I didn't do the bottom. Because, I mean, again, if I felt like I wasn't getting where I needed to go, I could try the bottom. But the whole point of it is to get rid of the square root in that top, or where I saw it originally. What do you notice then? The x minus 9's cancel. Don't forget, guys, it's not gone on top. What's on top? A 1. So now I'm going to try, what's the limit as x goes to 9 of 1 over the square root of x plus 3? Can I evaluate that? I can. What is it? One-third. Okay. Then let's try, I'll try one with more than just an x under here, just so you see that it's not really any more complicated. By using this strategy, because that kind of looks hard at first, but it didn't, by doing the opposite, those middle terms are always going to cancel, so you should never have to write them down. So let's try one we'll do one on the bottom with rationalizing. Okay, so on top I have an x. On the bottom I have 2 minus all under the square root x plus 4. So once again, let's try putting the 0 in the top and bottom. What do we get? 0 over what? Because if it was 0 over a number, it would be 0. But it's 0 over 0. Okay, because put 0 in here with 0 plus 4. 4 with the square root of 4. 2 minus 2 is 0. So I get 0 over 0. I can't find it by direct substitution. What do you think I'm going to multiply on this one? I want to get rid of this. 2 plus, that's the only thing I changed. We want this to be identical so we can get rid of the square root sign. So instead of 2 minus, I have 2 plus the square root of x plus 4. I'm going to do this on the top. Okay, so this time I want to just not simplify the top yet and see what happens. I want to simplify the bottom though, because that's where the square root's going to be gone. So I do that. On top I have x over 2 plus, not over, x times 2 plus the square root of x plus 4. Alright, let's do the bottom. What's 2 times 2? 4. I do plus 2 square root of x plus 4 minus. What happens there? They cancel. Then the last, a negative times a positive is negative, and what happens when you multiply a square root by itself? It cancels the square root symbol. Make sure you put it in a parentheses. You'll see why in a second. I have to subtract this whole thing. Okay, so let's simplify the bottom. Yep. You have to distribute this negative on the bottom. So I have on the bottom 4 minus x minus 4. What cancels? Okay. Now, at first you might be thinking, well, that doesn't really help me at all because I still have a 0, okay, and then I still can't do that. But what do you notice that you can simplify on the top and the bottom? I'll write it, I'll clean it up. What's left on the bottom is a negative x. What can I cancel out of the top and bottom now? A factor of x. Yep. So, yep. Now can I put in 0 and get a number? I can. So now I plug that 0 in, and we evaluate it. This is 2 plus 0 plus 4 is 4. The square root of 4 over 1. It should, Eden. Charlie Rancher for you. So what are we left with? Negative 4. Yep. That's when I was doing that. Once you get rid of the problem, the x in the denominator, then that's when we can use direct substitution.